Alright, for question A number 2. The diffusion of oxygen through the liquid limits the rate of reaction. Okay, sekarang ni maksudnya oxygen dah transfer into liquid phase and oxygen dah in liquid phase. No more in gas phase. So oxygen is in liquid phase, but the diffusion of oxygen for the reaction to occur, oxygen will diffuse into A for the reaction to occur, but the diffusion of oxygen tu sendiri yang very slow and it will limit the reaction. Maksudnya diffusion of oxygen in liquid phase very slow and limits the overall rate reaction. So you will have different mass balance equation. Okay, first write the mass balance. Okay, remember kalau diffusion of oxygen in liquid maksudnya oxygen already in liquid phase. So you need to calculate the to change the concentration of oxygen in gas phase to liquid phase. Alright, so mass balance again sama juga, still using the same assumption except diffusion yang rate limiting je will be different, because the first one reaction of oxygen in gas phase yang limiting, mass transfer of oxygen in gas phase yang limiting, but now diffusion of oxygen in liquid phase yang limiting. So we still use the same model equation, which is PFR. So UL dCAL per dZ equal to rate reaction, overall rate reaction in liquid phase, and the rate reaction is limiting by the diffusion. So the term rate reaction will be negligible, sama juga, but now it will be positive, A per 2V. Kenapa positif? Why positif? Yang the first one tadi negatif sebab loss of oxygen from the gas phase. Now oxygen dah masuk ke dalam liquid phase. So ada what we call it oxygen gain in liquid phase. So that's why positive. But why we need to divide with 2? Okay, because saya tulis habis dulu. Km mass transfer of oxygen in liquid phase, concentration of oxygen in liquid phase. Why we need to divide it by 2? Because the overall rate reaction based on pseudo homogeneous rate, we write the rate reaction is in terms of A. Okay, then 1A required 2 oxygen. So because we want to write the mass transfer for oxygen in liquid phase, so we need to consider the stoichiometry of oxygen. So stoichiometry of oxygen equal to 2. So that's why we need to divide it with 2. Okay, remember in reaction 1, negative RA per A equal to negative RB per B. So you bayangkan A is contaminant A, B for oxygen. So we need to divide it with 2. Okay, because we write the mass balance in terms of A, so that's why we divide it with 2. Okay, then next step again. First, we need to calculate the unknown value, which is A over V. A over V A over V sama macam the previous one. In in part 1 tadi. So 4 di over d naught square minus di square. Okay, so okay, A over V. So just insert the value, then you will get the value of A over V. And then KMO2 in liquid phase pun sama juga. Sherwood number 8 over 3. Diffusivity of oxygen still the same. Divide with DI. And then for concentration of oxygen in liquid phase, so you need to calculate it by using Henry's law equation. So CO2 in liquid phase sama dengan berapa? Okay, from Henry's law, first we need to determine the fraction of oxygen in liquid phase. So PO2 in gas phase, okay, partial pressure of oxygen in gas phase, multiply with the Henry's law of oxygen and multiply with the fraction of oxygen in liquid phase. So again, XO2 equal to PO2 divide with Henry's law constant. Oh, saya lupa bagi Henry's law constant of oxygen. But you can use the same value as question 1 in previous video ataupun previous slide. So 10 power of 5. So assume Henry's law constant of oxygen is 10 power of 5 atmosphere. So partial pressure of oxygen because 20%, so dia akan jadi 0.2 divide with 10 power of 5 atmosphere. Then you will get fraction as 2 times 10 negative 6 mol per mol. Mol O2 per mol solution. That's why dia tak ada unit because it is fraction. Then, okay, next page. Okay, concentration of O2 in liquid. XO2 in liquid multiply with the density of solution divide with molecular weight of solution. So yang ni dia tak mention pun oxygen, saturated oxygen ke apa. So we can assume the solution is water. Okay, so tadi 2 times 10 negative 6 multiply with the density of water 1 gram per centimeter cube. Because dia tak bagi pun jenis solution, so we just assume it is water. So kalau dia kata solution dia solvent yang lain, so the density will be given, molecular weight of the solvent also given. So you akan guna the given value. So in this case dia tak bagi, so we assume it is in water. So divide with molecular weight of water 18 per gram per mol. Okay. And then you will get the concentration of oxygen in liquid phase. So yang ni you kira sendirilah. Mol per centimeter cube, right? Then finally we can calculate the reactor length of reactor. So again you need to solve the the integration. So you will get L equal to CA0 minus CA, again CA equal to 0 because complete removal, multiply with velocity, and then ni bila you rearrange, solve the integration, you will get this equation. Di square and then you will get 2 as Sherwood number of oxygen ataupun SH di oxygen lah, Sherwood number for the cylinder 8/3. Diffusivity of oxygen, concentration of oxygen in liquid phase. So kita dah kira semua ni, just insert the value, then you will get the length. Oh, by the way, this value, so kalau kita tak letak negatif, sepatutnya ada negatif, walau even though dia positif, but okay, so yang ni you kira sendirilah. You will get the length in centimeter. Okay, dan saya nak terangkan pasal mass balance tadi. So because U dCl dCA per dZ equal to negative R equal to A/V km CO2 liquid. So saya kata tadi positif sebab gain, but negative sign here, negative sign in liquid phase. So kalau kita nak solvekan the mass balance equation, negative sign ni tetap ada dekat sini, U L D C A L D Z, because it's referring to the disappearance of A, even though mass transfer term is positive. So this is the actual mass balance equation. Barulah you boleh dapat this equation. Okay. And finally, to answer question B. Okay. Question B, you have the value, the length, compare the length of reactor. Compare the length of reactor for 2 different cases. So, kita nak choose yang mana? Which one? Satu akan bagi jawapan yang logik, another one tak logik. So, we will choose the answer yang bagi ni lah, length yang logik lah. Okay? And then later you compare case 1 dengan case 2, you will know the answer. Logik ke tak logik length of reactor tersebut. Then you will get the answer for question B. Plus, you need to consider the fact that mass transfer in gases is almost always much faster than liquid. So, itu dia punya keywords. Mass transfer in gas always much faster than in liquid. So, you will know the answer.